Welcome to Gradeful, where we provide online, one-on-one and small group SAT and ACT tutoring to students all around the world. If you're interested in finding out more about how we can help you to get ready for the big test, go ahead and reach out. Right now, we're looking at the October 2020 SAT Math section, Non-Calculator Section 3. Let's go ahead and get started. Question 1 is a very straightforward linear equation word problem. So it's coming from a y equals mx plus b. We're being told that to get the kayak, he had to pay $25, plus he had to pay $60 for every day that he had the kayak. So this is our basic linear y equals mx plus b equation for this situation, and he was charged a total of $325. So this equation, if you can think of it as starting at 25 and increasing at a slope of 60, it arrives at a final height of 325. So what we have to do for our equation is just set that equal to 325, and then we can start solving. So take away 25 from both sides, and divide by 60 on both sides, and we get x equals 5, and the answer for number 1 is B. Question 2 is a straightforward question on combining like terms. And to combine like terms, you need to look for the same signature. For instance, xy squared is the same signature as xy squared. So those two things will be combined. Just like x is the same as x, and these two 4s have the same signature because they don't have any x or y at all. So we don't really need this plus sign in the middle or the parentheses, because that would only be necessary if we were distributing something into this side, or maybe if there were a negative sign. But really we can kind of proceed as if those parentheses weren't there. So for the orange ones, the xy squareds, we have 2 of them and 3 of them, so we have 5 of them. For the red ones, the 3x and the minus 8x, we have 3 minus 8, which is negative 5. And it carries along an x, and for the blue ones, the 4s, we have minus 4 and plus 4, which cancel. So our answer is 5xy squared minus 5x, and so that's A for number 2. Question number 3 is kind of quizzing us on whether we know what this means, and most students will. That's the idea that you take the f of x function and you plug in x equals 2. Now what you really want to be ready for is if they had given you f of a plus b. There you would take your x and replace it with a plus b. Or even further, what if they said f of x plus 7? A lot of people would get thrown off by that. That would be the idea of replacing x with x plus 7. So the writers of these tests know what makes us more comfortable and less comfortable, so we have to be ahead of the game and be ready for anything they can throw at us. So nice and easy here, it's just asking us to plug in a 2. So f of 2 is 3 to the 2, so 3 squared, which is 9, and the answer for number 3 is D. Now we're looking at question 4, and on question 3 we saw a similar statement, and the idea was whatever's in that parentheses for the f of x statement, you just plug that in as x. So here, if this were an equation, we'd be plugging in x equals 0. Now, graphically, it's the same idea. We're looking for the moment when x equals 0, and so that means along the y-axis, which is this red axis here, we're looking for what happens when that is equal to 0, and in other words, when x equals 0, you're on the y-axis. So let's follow that y-axis down to where the curve is, and we see that when x is 0, the curve seems to be hitting the axis at negative 8. So what is f of 0? In other words, what is the height of the function when x is 0? And that is negative 8, and the answer for number 4 is B. Going over to number 5 now, we're definitely getting a lot of these f of x types of statements on this test. Earlier, we were dealing with the idea that if we saw f of some number, or let's say h of some number, that would mean you plug in x equals that number. But instead of plugging into the parentheses here, we're now being given the whole thing equal to some number. And so if the orange thing is x, then the blue thing is y. So this is basically telling us set y equal to -2. And what is y? Y is the whole function. So we're setting the whole function equal to -2. And then we're just going to go ahead and solve that. So first I might distribute that -4. -4x plus 4 plus 2 equals -2. Then combine like terms. -4x plus 6 equals -2. Take away 6 from both sides. -4x equals -8. And divide by -4. X equals 2. And our answer for number 5 is D. Question number 6 is a question on literal equations where they're just asking us to get one variable by itself. So here we're seeing which of the following expresses the temperature in degrees Rankine in terms of the temperature in degrees Celsius. And the temperature in degrees Rankine is the R. So the question is basically asking us to get R by itself. So let's just start by writing out the equation. To me, the quickest way to proceed here is to multiply by the opposite fraction. So 9/5 on both sides. And we'll get 9/5 C equals R minus 491/67. Now add the 491/67 to both sides and you get R equals the 9/5 C plus the 491.67, which is answer choice A for number 6. Question 7 is a unit conversion question that seems to be appearing more and more on more recent SATs. What we have is 75 square miles, so 75 square miles, and we're going to multiply that by x, but the unit, let's say, is unknown for now. Then we have 19 square miles, and let's say we'll be multiplying that by y with an unknown unit so far. But in the end, this is going to equal t, which the question tells us is the total number of residents. So let's just go ahead and write residents. And the question is, what needs to go in these spaces? What unit needs to go here in order to end up with residents? Now, when you do unit conversions, what you're trying to do is get a unit on the bottom that'll cancel out the unit on the top. So without knowing much else, we know that we need miles squared, square miles, in the denominator of this unit. Now if we need to convert it to residents, then it would make sense that we would need residents to be in the top. So if we were actually doing the math here, the next thing to do would be to cross out miles squared, and then that would give us 75x residents plus, cross out the miles squared again, 19y residents equals t residents, and it all makes sense. So what is the unit for x in this context, as the question says? It's the number of residents per mile squared, and that is answer choice D for number 7. Question number 8 is a nice basic quadratic equation question that can be solved two ways. I'm particularly interested in sharing with you the second way, but first I'd like to share the more basic way. If we have x squared minus 12x plus 35, that's just a nice quadratic. It's set equal to 0, which means we're looking for the y-intercept, because the y-intercept is the place where x is 0. And just from a factoring standpoint, we're looking for two numbers that add to the first number and multiply to the second number. So what two numbers add to -12 and multiply to 35? That would be -7 and -5. Now, if you're someone who struggles with factoring, when you try to think of what those numbers are, always think about what it multiplies to first, because there are only a certain very limited number of pairs of integers that multiply to 35, but if you think about it, there's actually an infinite number of pairs of integers that add to -12. For instance, 1,000,000 plus -1,012,000 would add to -12. So it's just way easier if you start with the numbers that it multiplies to. So the two numbers that do what we're looking for here, add to -12 and multiply to 35, are -7 and -5. So it factors to x minus 7, x minus 5, And now we have the zero product rule that says that if these two things multiply to 0, each one could be 0. So x minus 7 equals 0, x minus 5 equals 0. And you go ahead and solve each of those, add 7 to both sides here, add 5 to both sides here, and you have 7 and 5. So for method 1 that we're going to teach here, you have your two solutions, 7 and 5, and the sum of them is 7 plus 5, which is simply 12, and we're basically done. But keep in mind that these types of tests are not just trying to make you get the question wrong, they're trying to make you spend more time than you need to. So it helps to know that there are some important shortcuts for the sum and the product of the roots of a quadratic. The sum of the roots of a quadratic can be found with negative b over a, and the product of the roots can be found as c over a. Now what we're talking about is the a, b, and c of the quadratic. So using these three numbers that go in those three spots, we can just quickly get a shortcut for the sum or the product of the roots. So here, if we're being asked for the sum, we need to know that a is 1, it's the number in front of the x squared, b is minus 12, and c is 35. So the sum of the roots is going to be negative b over a, which is negative 12 over 1, so it's positive 12, and that is undeniably faster than finding the roots by the more conventional method. So a nice handy thing to keep in mind on your next SAT. Going over to question number 9 here, this is a question on a really important question on the SAT, which is the idea that cofunctions of complementary angles create equal expressions. Another way to say that is that if you have two angles, A and B, and those two angles add up to 90 if they're complementary, then we're allowed to say that the sine of one of those angles, the sine of A, equals the cosine of the other angle, the cosine of B. Now, the biggest thing that people get confused on in this concept is confusing the expressions, the sine of A and the cosine of B, with the angles, which are A and B. But the way it works is like a checklist. If you have cofunctions and complementary angles, then you'll have equal expressions. Or if you have cofunctions and equal expressions, then you have complementary angles. So the idea is if you have any two of the three elements of this rule, then you can assume the third to be true. In this situation, we have cofunctions right here in green. We have sine and cosine. Cofunctions are the idea of sine and cosine, tan and cotangent, or secant and cosecant. But to be honest, on the SAT, we've only seen so far sine and cosine. So we've got cofunctions. We also have complementary. And the reason we have that is that x and y and 90 should add up to 180. And that's because they are the three angles of a triangle. So if you went ahead and just simplified this by taking away 90 from both sides, you'd have x plus y equals 90. So right there in blue, we have the idea of complementary. So we have the cofunctions, we have the complementary, therefore we can assume that we have equal expressions. And what that means in this situation is we'd be allowed to say that the sine of x equals the cosine of y. We'd also be allowed to say that the sine of y equals the cosine of x. Simply put, the sine of one of those angles is equal to the cosine of the other angle in whatever order. So we've got here, the way they're asking it, it's the sine of x and the cosine of y. So that's this one, and those two things are equal. So what we're saying is that this expression here is equal to this expression here. And if the first one is equal to 5/8, then the second one is equal to 5/8, and we basically have a super easy SAT question if you're already prepped with the correct concept. Question 10 is a little bit of a monster, and I think the real moral of the story here is when you get a question that takes a long time, you should definitely do all of the other questions first, because one question is not worth missing 5 other questions. And if you're a tutor out there, if you had $1,000 for every time a student came back to you and told you that they didn't make it to the end of one of these tests, then you would not be tutoring anymore. And the idea there is just that people are wasting so much time on that one question that vexes them that then they miss out on all the rest. So, when you get that impression that a question is just a real headache and has a lot going on, the real thing you want to do to be successful on either an SAT or an ACT is just go ahead and move on and save it for later. But here we're looking for a shape that's going to give us a similar triangle to the one that's already provided. And in order to find similarity, we need to find distance. So another really important concept here is to never use the distance formula. Whenever you're asked for the distance between 2 points on an XY axis, just use the Pythagorean theorem. It's much more straightforward, and believe it or not, the distance formula comes from the Pythagorean theorem. It's exactly what you would get if you plugged two sets of XY coordinates into Pythagorean. So in my strong opinion, the Pythagorean theorem is a better version of the distance formula without as much of the possibility of making mistakes. The distance formula, it's got addition, subtraction, square roots. It's got so many things going on all at once that the chance of a mistake is way high. So what I mean by using the Pythagorean theorem for distance, for instance, if we were trying to find the distance between A and B here, we'd be looking at this red triangle here. And for that red triangle, it's got a horizontal length of 1 and a vertical length of 4. So we can go off to the side and say 1 squared plus 4 squared equals c squared. And like I said, these are the same numbers you'd be dealing with if you had plugged this into the distance formula, but you'd be doing a lot more work to get there. So 1 plus 16 equals c squared, 17 equals c squared, and c is the square root of 17. So that distance right there is the square root of 17. So going on to the distance between B and C, that's another right triangle. Every diagonal movement has a horizontal and vertical component, and we're using that in order to find the distance. So to go from a height of 2 to a height of 5, we went up by 3, and to go from an x value of 2 to an x value of 4, we went over by 2. So we can use those in our Pythagorean. 2 squared plus 3 squared equals c squared. And go ahead and just solve it out. 4 plus 9 equals c squared. 13 equals c squared, square root of both sides, and c is the square root of 13. Now, last but not least, to find the length between A and C, that has to do with this right triangle here. It has a vertical distance of 1 and a horizontal distance of 3, going from 1 to 4. So, Pythagorean again, 1 squared plus 3 squared equals c squared. 1 plus 9 equals c squared. 10 is c squared, square root of both sides. C is the square root of 10. So you got square root of 10 right here. And so now the three side lengths of triangle ABC are root 17, root 13, and root 10. So now, trying to figure out what we can do with triangle DEF, and we've only been given the coordinates of D and E, let's start by doing the same thing. Let's find the length from D to E. That length has to do with this triangle right here that has a horizontal component of 6 and a vertical component of 2. So 6 and 2. So let's just go ahead and calculate that out. 6 squared plus 2 squared equals c squared. 36 plus 4 is c squared. C squared is 40. The square root of 40 is the square root of 4 times 10. 4 is 2 times 2. 10 is 2 times 5. And to simplify a square root, a square root is saying what number multiplied by itself 2 times gives you that number. So we're looking in square roots for groups of 2. In cube roots, we'd be looking for groups of 3. So here we have these 2 that we can cross out and put 1 outside, and that gives us 2 on the outside and 10 on the inside. So the length from D to E is 2 root 10. And surprisingly, that kind of lines up with this one here. So one theory we can develop at this point in our process is that we've got 2 root 10, and in theory, the other two sides of the triangle can be 2 root 13 and 2 root 17. And so this would take a really long time, but the only way to really get there is to try out the remaining points and go ahead and measure out the distances like we've been doing until we find a point that gives us the 2 root 13 and the 2 root 17. And like I said, that takes a really long time, so you don't want to be doing this unless you've done the other 19 questions in section 3 already. And you do want to practice this Pythagorean method of getting the distance and be so sharp at it that you can get it done without wasting a lot of time. So assuming that we tried all of the answer choices, the one that will end up working here is going to be B. So let's just go ahead and test that one out. If we had 4 and negative 10, so I'm going 4 on the x-axis and negative 10 on the y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that puts us right here. That's the point 4, negative 10. So we're just going to draw out the triangle like that. And we're going to measure out the other two sides of that triangle. So if we measure out, well, first of all, this is point F in theory. So let's measure out the length of segment EF with this green right triangle here. It's got a horizontal component of, let's see, well, first of all, this point here is, as we said, 4, negative 10. So the horizontal component of the movement is going from 4 to 8. So that's a distance of 4. And the vertical component of the movement is going from negative 10 to negative 4. So that's a distance of 6. So to do that Pythagorean, we're going to want to have 4 squared plus 6 squared equals c squared. That's 16 plus 36. Adds up to 52. And we need the square root of 52, which is really the square root of 4 times 13. And 4 simplifies to a 2 on the outside. Now, by the way, to keep consistency on the methods, what I just did in my head is I imagine that 4 is really 2 times 2. And because we're looking for groups of 2, if you cross that out and put it on the outside, you get 2 root 13. So that distance is a distance of 2 times the square root of 13. And so that matched up with this length. We had, in the beginning, we had root 10 for side AC, and that matched up with 2 root 10 for side DE. Now we found that side EF is 2 root 13, which matches up with the root 13 we had for side BC. And so the idea is that we're going from root 10 to 2 root 10, root 13 to 2 root 13, and last but not least, side DF should have a length of 2 root 17, and let's test that out. There is a horizontal component of 2, which you can just look at and count right there, but the vertical component goes from negative 2, a height of negative 2 to negative 10, so that's a length of 8. And so to do that Pythagorean, we need 2 squared plus 8 squared equals c squared. 2 squared is 4, 8 squared is 64. So we have 68 equals c squared. And 68, we're going to go ahead and take the square root of that. And 68, surprisingly, is 2 times 2 times 17. So like we've been doing, we'll take out a group of 2 and put it here, and that gives us 2 root 17 for that distance. And that's exactly what we had in mind, because the 2 root 17 continues the trend. We went over from root 17 to 2 root 17. And now every single distance in triangle ABC is paired up with a corresponding distance in triangle DEF with a factor of 2. So the point that creates two similar triangles is 4, negative 10, and the answer for question 10 is B. Now we're going to question 11, and question 11 is just a system of linear equations. And for a system of linear equations, you definitely want to lean toward the elimination method whenever possible. So what I'm going to want to do is subtract x from both sides here. Negative x plus y equals 3. And keep this one the way it is. 2x minus y equals 0. And what we can see when we have it set up this way is that this is very amenable to the idea of just canceling the y's from the beginning. So let's just go ahead and take the opportunity to do this question in the easiest method possible and just add straight down. And we have x, the y's cancel, equals 3. And just be really careful not to pick this here because they're not asking us for x, they're asking us for y. And that's the brand of difficulty, that's the brand of challenge that the SAT will give you a lot of. So always be aware of that kind of thing. If I find x, they may be asking for y. If I find x, they may be asking for x minus 5. So just be careful. And we'll go ahead and just plug that into one of the original equations. Y equals x plus 3. So therefore y equals 3 plus 3 because x is 3. And y equals 6. And the answer for 11 is D. Question number 12 is quizzing a concept that is coming up really frequently. It's almost one of the few things that we can guarantee will come up on any SAT that you're going to take. So the idea for exponential equations is that the basic equation looks like this, and you need to know what each part of this represents. So A is your starting amount, B is the way that it changes, and x is the number of times this is all going to happen. And there are two classic ways that the SAT will spin this. On the one hand, I can have y equals a times b to the x over 3. And on the other, I can have y equals a times b to the 3x. So assuming that x is in years, then the one on the left would say that this is happening every 3 years. So x over 3 is once every 3 times this thing happens. And this makes sense if you think of the number 6. If x equals 6, then the exponent itself would be equal to 2. And this entire process would get triggered 2 times, which makes sense. If something's happening every 3 years, then in 6 years it would happen 2 times. So this other one is the idea that it's happening 3 times per time period. If we're thinking about years, then that would be 3 times per year. And so you want to be really familiar. You have your fundamental exponential equation, and you have what it turns into if we have the fraction over a number, or if we have the exponent multiplied by a number. So let's go ahead and apply that here. This is saying that we're starting at 50 liters of fluid in the tank. It's going to be doubling every time period, and that's just going to happen every t. If t is in hours, that's once per hour. Nice and straightforward. Now, if we're doing that in minutes, if it's happening once per hour, then that would mean it's happening once every 60 minutes. So that exponent in minutes would be m over 60. So once again, once every hour, which would be just to the t hours, is the same as once every 60 minutes. That's the m over 60 minutes. That's this idea right here. If it's happening every once in a while, you're dividing by that number. So it's starting with 50. It's still doubling, but in the language of minutes, that's happening once every 60 minutes instead of once per hour. And that matches answer choice A for number 12. Question number 13 is a really strange and challenging question type that comes up at least once on every SAT. And I'm going to explain this with a lot of care. This question itself may not be the toughest question in the world, but the concept itself is something that if you're someone who's really trying to get a top score and get into the top schools, you need to be very, very secure in this concept. Now, the concept is the idea of seeing an equation as the expression of an intersection. Now, there's a big backstory there. On a whole other question type that you're going to see on the SAT, if you're given multiple equations and asked for the solution to those multiple equations, what you're really being asked for is an intersection. And another rule that you need to be really sure of is that if you're asked for an intersection between two functions, whenever possible, you want to just get the two functions in the y equals format and set them equal. So with so many questions being asked in so many challenging and peculiar ways, you benefit from doing things the same way each time. So if you can just be in the habit of getting two equations in the y equals format and setting them equal, you'll make things easier for yourself. Now, it follows from that if for an intersection we're getting two equations in the y equals format and setting them equal, then the opposite of that, maybe we can think of it as the converse, is the idea that if I see an equation, if I see two things set equal, that might have been the expression of an intersection. So in this situation, we're seeing an equation, and we can think that maybe that was y equals 3x plus 8 and y equals kx plus 8. And what we're seeing is the expression of them as an intersection that's kind of already been done for us when it was set as 3x plus 8 equal to kx plus 8. And, if you're hearing this and wondering to yourself, how would I identify this question type? The advice that we have for you is practice, practice, practice. This question comes up once or twice on every single SAT. And if you really want to get your best score, it's up to you to have practiced all the SATs you can get your hands on and to have a reference. When you see this question, you're not just thinking about this question, you're thinking about all the times that similar situation has come up on different SATs. So now what we're talking about is two linear equations, and we're talking about the ways that they can interact on an XY axis. And there are three ways that can happen. They can hit never, two lines can hit once, or they can hit all the time if you graph them and realize that they actually were the same line all along. So in the instance of having one solution, that means that the slopes are different and the y-intercepts are different. You actually could have the same y-intercept here, but we're talking about what's going to happen most of the time. Most of the time they'll have different y-intercepts. For no solutions, and the reason there's no solutions here is that the lines are never intersecting and the intersection is the solution. Here we'll have the same slopes, but we'll definitely have different y-intercepts. Because if we had the same y-intercept, it wouldn't be two parallel lines, it would be the third scenario. So if you have no solutions parallel, then you automatically know that means you have the same slope and different y-intercepts. And in the last one, that's called infinite solutions. The solution is the intersection, and these lines are always intersecting. There, you'll have the same everything. You'll have the same slope and the same y-intercept. So you can just pay attention to the clue that's being given to you here. Here we have one solution, and that means that we have different slopes and most of the time different y-intercepts, but definitely different slopes. So what are the two slopes for the two equations here? If you're thinking about how this is a y equals mx plus b format, the slope is the m, so it's the 3 for the left side, and it's k for the right side. So if the slopes have to be different, then we know that k cannot equal 3. So which of the following could not be the value of k? The answer is 3 by definition, and so the answer for 13 is C. Now question 14 seems to me to be a question that's imitating the idea of the zero product rule. The zero product rule comes up when you have these different parentheses and they're set equal to 0 on one side, and so you would take the parentheses and set them each equal to 0. And so this kind of seems like a decoy that was meant to make people kind of think of that situation, but it doesn't apply because the zero product rule works when one side of the equation is equal to 0. So here we have to actually start simplifying to make something like that happen. So if we distribute the left-hand side, we'll get x squared minus 4x. And if we were to FOIL the right-hand side, we'd have x squared plus x minus 1. And this is a quadratic situation because it's got x squared, so we're going to want to set it equal to 0, but it's even easier than that because if we just go ahead and take away x squared from both sides, it becomes a much easier situation. Minus 4x equals negative 1. And that's also because x minus x cancels out. And so we're just left with minus 4x equals negative 1. Divide by negative 4 on both sides, and you get x equals 1 over 4. And how many solutions are there? Well, we found that solution, and there's only one of them. So the answer for 14 is B. So now we're going to question 15 here. We've got 2 to the 2 over n, and then we've got the nth root of 3. So that nth root of 3 is really the nth root of 3 to the first power, because if something doesn't have an exponent, then it means it has an exponent of 1, an invisible number 1. And the rule that we're going to apply here is the idea that if I have the a root of b to the c, then that's the same as b to the c over a. And the way I think of it is that you've got b to the c and b to the c, But the a that's right here kind of slips into this part of the radical. So it kind of comes around and goes right there. That's how I think of it. But in any case, you need to know that if you have the a root of b to the c, that's b to the c over a. So if we have the nth root of 3 to the 1, that's 3 to the 1 over n. And so we've got 2 to the 2 over n and 3 to the 1 over n. And if we convert those both to radicals, that's the nth root of 2 squared and the nth root of 3 to the first. Now here we have it in a critical moment, because if I had the square root of x times the square root of y, then that would become the square root of xy. And the reason we can do that is that we've got the same exact radical both times. And if you have matching radicals, then yes, you can multiply what's underneath. By the way, if I had the square root of x times the square root of x, that would just be x. And that's because the radicals cancel each other. It's really the square root of x squared, and it simplifies. But it definitely helps to have these two rules right there at the forefront of your mind when you're doing these kinds of questions. So the idea is, because we have the same radicals, we have the nth root both times, we can multiply what's underneath. So this would be the nth root of 2 squared, which is 4, times 3. So the nth root of 4 times 3 is 12, and the answer for 15 is D. Question 16 is asking us to demonstrate our understanding of vertical and horizontal lines. If we go ahead and just graph this situation real quick, we have the point 2, 0, 2, 1, and 2, 2. And you can see that if we're graphing all of the points that have an x value of 2, we get the line of x equals 2. And so if I were ever given the line x equals 2, I want to think of that as all the points that have an x value of 2. And like I said, if you graph that, you'll see that that's a horizontal line. Similarly, if we had something like y equals 4, that would be the collection of all the points that have a y value of 4, and it would draw out a horizontal line. So we want to have that firm understanding of vertical and horizontal lines. So here, this is the equation x equals k, and it's the equation x equals 2. So what's k? K is 2, and that's our answer for number 16. Question 17 is just asking us to solve a nice simple equation. If we take away 4x from both sides, minus 4x minus 4x, that would give us 8x plus 6 equals 8. And then if we take away 6 from both sides, we get 8x on the left and 2 on the right. Then maybe we can divide by 8 on both sides, and x equals 2 over 8, which is the same as 1 over 4. And surprisingly, College Board claims that they accept unsimplified fractions as correct answers on the SAT. So if you wanted to save yourself a millisecond, you could maybe bubble in 2 over 8 here, and according to the instructions on the SAT, that would be considered correct. But the answer for 17 is 1/4, or 2 over 8. Question 18 is asking us about right triangle trigonometry. So if you're not sharp on SOHCAHTOA, then you want to get yourself sharp on that as soon as possible. That's the idea that sine is the opposite over the hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. And the way it works is, if you have a right triangle, the angle that you're working from is what we call theta. So we're talking about the cosine of b. That means that theta is angle b. And we have D here and E here for the smaller of the two similar triangles. And the first thing you do is you go straight out from theta and call that side your opposite. Then you have your hypotenuse, which everyone knows what a hypotenuse is the side across from the right angle. And last but not least, the one left over is the adjacent. And if what we're looking for is the cosine, then we're looking for the adjacent over the hypotenuse. So if we just arrange adjacent over hypotenuse, we already know the side lengths, 8, 10, and 6. So the adjacent is 6, the hypotenuse is 10, and so the answer to number 18 is 6 over 10, which also simplifies to 3 over 5. Question 19 is quizzing us on the 3 ways that two lines can interact. Once again, like we said on an earlier question, two lines can hit once, where you would have a different slope and usually a different y-intercept. They can hit never, where you have the same slope and always a different y-intercept, or they can intersect all the time, where you're going to have the same slope and the same y-intercept both times. So here we're being told that this system has no solutions, so it's the middle scenario where you're going to have the same slope and different y-intercepts. So what's the slope of the given line? From the 2 points that were being given, it's going up by 1, 2, 3, 4, 5, and going over by 1, 2, 3, 4. So the slope is 5 over 4. And if the second equation looks like this, when we arrange it in the y equals mx plus b format, the slope should be 5/4. So let's just go ahead and take away ax from both sides, and it would be negative ax plus 1. Now the instinct is to put the x before the number because we're talking about the format y equals mx plus b. So you want the x first. Divide them both by negative 1 and you'll get y equals positive ax minus 1. Now if the slope is 5 over 4 because it has to be parallel to the original given line, then that means that a is 5 over 4 and 5/4 is the answer to number 19. And now we're going over to question 20. We have a function, and it's being given that it's in this format. And you want to look at that and immediately identify that with the basic format of an exponential equation. And as we said on an earlier question, the a is the starting amount, the b is how it changes, and the x is the number of times that can happen. So how is this thing changing? Well, as x goes from 0 to 1 to 2, which would happen in virtually any equation, y is going from 9 to 12 to 16, so it's being multiplied by something. But how can you figure out what's been multiplied? The answer to that is very clear, by going in the opposite direction and dividing. So if we did 16 divided by 12, or 12 divided by 9, the answer there is going to give us the exact same thing that we would have had to multiply by to go in the forward direction. So 16 over 12 simplifies by 4, that gives you 4 over 3, and 12 over 9 simplifies by 3, and that gives you 4 over 3. And so the thing that we're multiplying by, the b, is 4 over 3, and the question is asking us for exactly that, the thing that you're multiplying by. They're calling it r, but we call it b, and in any case, it's 4 over 3 for question 20. Thanks so much for joining us. Grateful offers online, one-on-one, and small group tutoring for the SAT and the ACT, and we do that with students all around the world. If you're interested in finding out more about how we can help you to prepare for your next big test, go ahead and reach out. We'd love to hear from you. Have a great day.